Thank you for joining us today as two senior scientists from Par Instrument Company introduce the newly developed high-pressure, high-temperature rotating cylinder electrode system. This device can be used for laboratory evaluation of corrosion inhibitors commonly used in refinery and oil field equipment in accordance with ASTM G170.
Hi, and welcome to our presentation. I'm Andre Yermolayo, and I do research and development for Par Instrument Company, and I have an extensive background in physical chemistry.
And my name is Tim Kilcoyne. I am a senior technical sales representative here at Par Instrument Company. I have a PhD in chemistry. I sell stirred reactor systems and some customized systems for our company.
And today we are proud to show you our new addition to the Par product line. This is high pressure, high temperature rotating cylinder electrode for corrosion studies. And let's take a closer look.
The RCE system that is being offered by our company is a stirred pressure reactor system based off of our 4520 series reactors. The system has approximately a 1 liter volume that has a maximum allowable working pressure of 2900 psi and a maximum allowable working temperature of 200 degrees C because of some of the components that are part of this system. It will have alloy C276, also known as Hastelloy C, as the material of construction for the surfaces contacting the liquid phase of the system. Testing can be performed at rotational speeds ranging from 500 to 2500 RPM. The rotating cylinder coupon has a 1/2 inch OD. There are two 3/8 inch NPT ports on the head for mounting the required reference and counter electrodes needed for the corrosion testing.
This RCE is based on a standard Par reactor and has standard features familiar to Par reactor users.
This is a fixed head system, which means the head is conveniently fixed to the support plate on the stand with a machined flange. The head can be removed from the stand when necessary for servicing or cleaning. The cylinder is pressure sealed to the head with a bolted split ring closure that allows the flat gasket to be compressed with a specified maximum torque to each bolt. The gasket is confined to the groove in the head that lines up with the sealing lip of the cylinder shown here.
Now let's talk about the heart of the instrument that makes it special, the rotating cylinder electrode design.
The magnetic drive that serves as the working electrode for this system has the following design features. The wire leads make electrical contact with this shaft in the brush housing section of the magnetic drive. There are duplicate electrical wire leads to ensure proper electrical contact with the rotating shaft. The magnetic drive is pressure sealed to the fixed head of the pressure cell. A coated isolated shaft makes direct contact with the rotating cylinder coupon inside the working electrode isolation assembly. The working electrode isolation assembly consists of PEEK components that allows the machined 1/2 inch OD rotating cylinder coupon to be mounted for corrosion testing. We can supply 1018 metal coupons for commissioning the system and could sell coupons of other materials for an additional cost.
The RCE system includes reference and counter electrodes. They can come in different flavors, but let's look at a standard offering.
The core instruments probe that serve as the reference electrode and the counter electrodes are pressure sealed to the head with a 3/8 inch NPT port and a 3/8 inch NPT compression fitting. The reference electrode is a silver chloride high pressure, high temperature core instrument probe, which is refillable and can be used up to the 200 degrees C temperature conditions of the system. It can be supplied for the pressure rating of the system also. The counter electrode is a 1 mm OD platinum core instruments probe. They are mounted through a compound angled port into the head of the pressure cell. Every RCE system shipped from Par Instrument Company will include a factory test data set collected using a 1010 series Gamry potentiostat. The 4848 PID temperature controller that will accompany every RCE system will have a primary temperature module, the motor control module with a tachometer display, and a pressure display module. The RPM can be operated manually too, with the included local adjustment knob when switched into that position. The primary temperature module includes the meter that allows the user to set the temperature for corrosion test run and display both the set temperature and process temperature. The motor control module allows someone to input an RPM value when operated in the automated mode and will display the RPM value during operation. The pressure display module will provide a digital pressure that can be logged with the provided SpecView software, but is only a function of the pressure added to the system or the pressure from the system as the temperature fluctuates. The pressure is not controlled, it is only being measured. There are optional temperature measurements that can be supplied as part of the system.
The 4848 controller can be remotely controlled from a gamma sequencer via provided communication interface. Thus, measurement sequences can be performed in fully automated mode, minimizing operator time. Typical power rotating electrode experiments are corrosion rate measurements conducted using linear polarization resistance and electronic impedance spectroscopy. Here you can see the example of such corrosion rate dependence on the rotation speed of coupon.
We're glad you came to our presentation and thank you for being with us on this conference.
If you have any questions, please call us or email us.
Thank you for watching and see you around.